Okay, so we are moving on to misrepresented data. This is very common in media. This is a huge skill to have to be an informed citizen when you maybe look at YouTube videos, when you look at the news, when you read graphs online. It's very easy to see misrepresented data in our everyday lives. So graphs can create false impressions by the way that they are drawn. Pictographs can use different size symbols, bars can be different widths, and I mentioned that in the first video. You can start the scale at a number other than 0. A part of the graph may be treated differently to draw attention to it, and there might just be a poor scale. So, our first example is distorting the scale. So Matthew's math test scores are displayed on the bar graph. According to the graph, what did Matthew receive on each test? So if we look, test 1, T1, he received a 60. T2, he received maybe a 65. T3, a 68, and T4, a 69. From the graph, what appears to be true about Matthew's improvement over the 4 test scores? Well, it appears to be true that he improved with each test. However, this distortion rate here, like this is only 5 points of difference. 5 points. So he distorted the scale. He made it seem like he had a huge improvement. Not necessarily true. So, how should the graph be drawn more accurately? Scale should start at 0. Or scale should be appropriate. That kind of little break in the graph, I don't think I spelled that right, is fine. We use that in science when we have like a large set of data that doesn't matter. But if he had just started the scale, I did not mean to make that look like a break in the graph. He had started it at, let's say, 50, and then went up by 5, so then 55, 60, 65, 70. We could see that he would have one test, sorry, not there. He would have one test up here at 60. He would have his second test at 65. He would have a third test at 68. So then that would be like right there maybe. So that shows a small improvement. And then the last one at 69, so then an even smaller improvement. So we can see that we have a little bit more of a gradual step rather than that giant jump from the first one. So D, what would be a more accurate conclusion about his improvement? Well, that's right here. He improved with each test. For A and B, he made it seem like he had a huge improvement, even though that wasn't necessarily true. And C, the scale should just be more appropriate. And D, again, it was small improvements, not a huge improvement. Distorting the values. Right here, I can see that something is wrong with the pictograph. Looking right at the pictograph, I think that fish should be the favorite, and that's because the fish is larger. Looking at this, it's kind of hard to see right off the bat if more students like cats or dogs, but I think it's dogs because looking, I do see one more symbol than I do with the cat. And how should the pictograph be redrawn to represent the data more accurately? All symbols should be the same size. Should be the same size. Because, like I said, well, even look at this. I was wrong. This cat and dog thing, they're the same. but it seems like it's more dogs because it's slightly longer, but they're the same. They're the same. There's 4 of each. That got me. That's some good misrepresented data. Okay, distorting the size of bars. So that's thinking back to they draw more attention to a certain part in order for you to kind of get interested in what's happening there. So we have A to B. From graph A, how many times more are the sales of the 3 desktops? Wait, desktops to laptops? Yeah. So then desktops, there is 4,000, and laptops, there is 2,000. So then there is twice as many. And that's an accurate representation. Like I can kind of see that, yeah, there's definitely more desktops than laptops. And it looks about double because the bars are the same. From graph B, how many times more sales are there of desktops than laptops? Well, it's the same, but graph B could be misleading because the desktops is much wider. I don't know why that happened. It's much wider, which means somebody could look at it. Someone could think maybe 3 times as much. Rather than just double, because not everyone's going to look to make sure that the scale is accurate or to look and compare these two values here. They would just look at it and be like, ah, yes, desktops, way more. I can see it's wider, I can see it's taller, maybe it's both, so 3 to 4 times as many, which would just be crazy. Next you have practice in the book, practice in the textbook. Answer keys will be posted for you. Take your time. And yeah, if you have any questions, please let me know.